Welcome to our final lesson in this calculus course, rectilinear motion. What's old is new again. We've already done this topic, so why are we doing it again if we've covered it? Well, we're doing the reverse. The first time we encountered this topic, we were talking about derivatives. We started with the position function, and then the derivative of that gave us the velocity. The derivative of velocity gave us the acceleration, and then we did those diagrams. Don't worry, today you don't have to do the diagrams. We've done that already. You know how to do those particle diagrams. Today we're going to do the reverse. If I give you the acceleration, can you work backwards to figure out the velocity or the displacement? So that's all we're doing today. Should be a nice, easy lesson to end this course on. Okay, so in the example in your notes, we say that the particle moves in a straight line. The acceleration is given to us. The acceleration a of t is 6t plus 4. They tell us the initial velocity is minus 6 centimeters per second, and displacement is 9 centimeters. Based on the information, we want to figure out what the position function s of t is. So very easy for us at this point. Like I said, no more diagrams. We did a lot of that work earlier. We can just do the antiderivatives. So if I give the acceleration, the antiderivative of acceleration is velocity, right? Because about a month ago we learned the derivative of velocity is acceleration, so the antiderivative of acceleration is velocity. Feel like we're back in physics? I know you have physics right now, so just think about you're studying and preparing for calculus and physics at the same time. So let's get the antiderivative of 6t is 6t squared over 2. 4t is 4t, 1 over 1, but we don't need that. And again, don't forget, you do need to put the plus c. We're finding the most general antiderivative. We can clean that up a bit. That gives us 3t squared plus 4t plus c. And in the question, they told us that the initial velocity was minus 6. Now, if you remember back when we solved for it the other way, to solve for our c value, we would set all of our t values to 0. And if we did that, that means that our c value is minus 6. So based on that, they gave us the acceleration. And from the acceleration, we figured out that the velocity is 3t squared plus 4t minus 6. But unfortunately, that's not what the question asked us. They didn't ask us for velocity, they asked us for the position function. So we keep going because the antiderivative of velocity gives us position. So on the next slide, I already have the velocity function out. So the antiderivative of velocity gives us the displacement. So let's keep doing our antiderivatives. This gives us 3t cubed over 3 plus 4t squared over 2 minus 6t. Now, we've already used the letter C to represent something, so I'm just going to use D because we've already used C within this question already. So we can clean this up a little bit. This gives us t cubed, 2t squared minus 6t plus D. And again, the initial question told us that the original displacement was 9. And again, to solve for our t value, at that point, we would be setting all of our t's to 0. It's just the reverse of what we did when we worked through it the other way. So doing that, our d value is 9. So the question asked for the position function. So based on that, the position function should be t cubed plus 2t squared minus 6t plus 9. Okay, a nice easy lesson for us to end this course on. Congratulations, you still have an assignment and a final exam to go through, but congratulations, you've made it through pandemic and you've made it through calculus. What a way to end your grade 12 graduating year. So good luck, hang in there, and good luck on your final exam.